Um, Criteria are standards, like minimum requirements or regulations, you know? So in the United States, we have 6 types of air pollution that we regulate at the federal level, and that's a surprisingly small amount. Um, I got to remind you that when we talk about the criteria pollutants, we're just talking about the United States. So you could go right next door to Canada or Mexico or across the ocean to successful countries like Germany and England, and they would have entirely separate regulation. This is for the US. A little bit of background, you should know that smog was really spooky. And in the 1970s, the American public was warming up to the idea of activism. And we started to demand environmental regulations. We actually had a whole bunch of environmental regulations during the presidency of historically one of the least environmental people ever. Richard Nixon used very unkind, colorful language to describe environmentalists. He was not himself an environmentalist. He actually was ardently opposed to environmental regulations, but the people of the United States overwhelmed his personal views. And we created a number of laws that regulate air quality during Richard Nixon. There's some stuff that was left out that today you would probably want to regulate, like carbon dioxide and methane, because they didn't have a direct effect on health. We also did not know that fluorinated gases wrecked the ozone layer. So some stuff we didn't know about and some stuff we didn't care about. This was more about human health, not about environmental issues. You should know that we have regulations all over the place for this. So there's little laws that just govern a certain type of power plant. There's laws that govern what Home Depot can sell you or how it's labeled before you use it. But we regulate at the commercial, industrial, domestic level. We should also be really clear that everything I'm about to discuss is here in the troposphere, not up there in the stratosphere. This is close to Earth, near us. There are 6 criteria pollutants. You have to know them all. Particulate matter is also known as PM. That's just an abbreviation. And a lot of this is natural, like pollen or ashes from a wildfire or sand, but humans do add a lot. You should know that the smallest are the worst. The big stuff actually gets filtered by our boogers and our hairs, but the little stuff gets through all of that. So fine particulates are much more dangerous because our body can't trap them on the way in. We'll talk about the sources in an upcoming slide. Lead is largely regulated now. It used to be a very common ingredient in consumer products. Lead is very common in nature. You can find huge natural deposits of lead. That's why it's so cheap. So it's pretty regulated now. Remember that lead is not dangerous outside your body. It doesn't really travel through your skin. I work with lead all the time. But as soon as it enters your bloodstream, it's basically there forever. And we do have one common lead issue in the United States today, which is that we have a lot of old pipes that were made from lead, and that's fine because lead doesn't really dissolve into water when the water is clean. So like the shooting range is at the top of a watershed and there's no lead reaching the water of that watershed because it's just rainfall that hits that lead. But when rain becomes acidic, heavy metals dissolve more. So if you have acidic tap water, if the water is acidic and then it goes through lead pipes, Flint, Michigan. People of Flint are getting lead poisoning from their tap water, not just because the pipes are lead, but because their water is acidified before it goes through those lead pipes. That's an important detail for you to know. Criteria pollutant number 3 is nitrogen oxides. You'll notice that my screen says NOx, where the X is a variable that represents integers. So nitrogen monoxide or nitrogen dioxide are both possible. These come primarily from transportation fuels, so mobile sources, gasoline from cars, jet fuel from airplanes, diesel in trucks, tanker fuel in tankers. And NOx are not that big of a whoop on their own, but they're very reactive. NOx plays with other stuff. So NOx is an ingredient that produces secondary pollution. So it makes acid rain, for example, that's a secondary pollutant, and it makes other types of oxidants like ozone and peroxyacetyl nitrates and a bunch of other oxidants. So NOx are dangerous. They're a primary pollutant that results in secondary pollution. Carbon monoxide is super toxic because it keeps you from breathing. So hemoglobin carries oxygen unless there's carbon monoxide around. Hemoglobin prefers carbon monoxide to oxygen. Carbon monoxide is super toxic. Most of it is actually natural, but humans do add a little bit, and it's important. Like naturally made carbon monoxide doesn't usually reach humans because carbon monoxide doesn't last very long. But if you're nearby when there's carbon monoxide, like you're trapped in a car cooking on a crappy camp stove, you can die from that because basically you go to sleep, you just don't get enough oxygen. It's like you're slowly suffocating, you don't even notice. You might know that people back in the day would use a hose connected to their tailpipe to kill themselves in the garage or inside their car or whatever. That's only with old cars. It takes really crappy cars to produce that much carbon monoxide. There's a famous scene in House of Cards where somebody kills somebody else by leaving them in a garage with a running car. That was a modern car. They would have just woken up with messy pants, but they would not have died. The car would have shut itself off. The reason I mentioned this is you should remember that there has to be something incomplete about the combustion, not enough oxygen. It's inadequate combustion to make carbon monoxide. Crappy technology, cooking inside of a tent or a car or an RV, people who use like crummy wood fires where the chimney is all choked up and they don't have enough oxygen going in, whatever. Sulfur oxides are also known as SOx. Kind of the same thing, no big deal on their own, but they mix with other stuff. Sulfur is really dangerous for humans because it's often associated with ash particles, so it gets stuck in your lungs and then it acidifies your blood, which really changes your blood chemistry. And there are some small amounts from chemistry in the soil and from volcanoes, but humans do add a lot. And I want you to think of coal. Anytime you see SOx, think coal. And anytime you're talking about coal, say SOx. Those things go together, like peanut butter and jelly. Yeah, the most common ones are SO2, SO3, and SO4. That's why we use the X, because there's a lot of numbers that could replace that X. And oxidants are the 6th criteria pollutant, and I have to warn you, this one is tricky. Heads up. First of all, oxidants are a thing in chemistry, and understanding how that interacts with your body is really tricky. It affects like sensitive tissues. If it gets into your blood, it affects your internal chemistry. Oxidants are just electron acceptors, which doesn't mean anything if we're not talking a lot of chemistry, but basically they break bonds and they slow natural reactions inside of your body. So they can really damage your DNA, leading to mutations, cancer, so on. They can affect oxygen transport in your blood. They can give you, like, you can sting your eyes and make it hard for you to breathe. They can affect your nervous system, your digestive system. So oxidants are super dangerous, but it's tricky to explain why. Go back and do that again and try to write down the action words I just said. Critical concept, oxidants are a secondary pollutant. So we don't make oxidants directly. We make the ingredients that in the atmosphere, voila, become oxidants. Since we can't regulate what the atmosphere is going to do, we have to regulate the ingredients themselves. So we can't regulate the oxidants directly. We got to regulate the parts which become oxidants. And there's this category of chemicals. This is like a trillion possible chemical compounds. And you don't have to know a ton of chemistry, but this is chemistry you got to know. These are little highly reactive hydrocarbons, hydrogen, oxygen, carbon, hydrocarbons, that we call volatile organic compounds. And you got to know that, VOCs. You have to know that. It's all over the AP test. VOCs are volatile, meaning that they react with other stuff. They're organic, so they're built on carbon, and they're a compound. They've got other stuff stuck on there. You notice we talk a lot about carbon chemistry because all the chemistry that we do is carbon-based. You get VOCs from chemistry that happens quickly, like you spray paint and then it dries really fast, or PVC glue that like melts the plastic and then it cures and hardens really fast, or like acetone to remove fingernail polish. That's rapid chemistry, right? Like a solid becomes a liquid or a liquid becomes a solid. Those things that have rapid chemistry that you can see with the naked eye, rubber cement, solvents that like make plastic shiny or that melt rubber or whatever. Rapid chemistry is a source of VOCs. The College Board might not like it if you said rapid chemistry. That's for you to remember. So cement, PVC glue, acetone, some lubricants like the fizzy lubricants, things that come like in a spray can, things that make rapid chemical reactions. When you burn fossil fuels, there's often little leftovers, things that didn't burn. So dirty fossil fuels have more impurities. They're going to leave more stuff stuck to carbon, right? Because it didn't break that bond. Fossil fuels are a lot of other chemicals stuck to carbons too. So the dirtier the fossil fuel, the more VOCs you get. That's important to know. And the most common ones that you should know are ozone and PAN, P-A-N. There's a whole bunch of other chemistry. I don't know why they expect you to be so good at chemistry, so I'm just trying to give you the cliff notes. Ozone and PAN, peroxyacetyl nitrate. If you ever see peroxy something on the AP test, you should probably know that's an oxidant. Peroxy, like hydrogen peroxide. The peroxy part means there's a lot of oxygen. Remember, oxidant. Peroxy. There's a bazillion possible ones. We can't regulate them all because the chemistry happens in the atmosphere, so we regulate the ingredients. You're going to need to pause and write in a minute. Here you see the 6 criteria pollutants and their main sources. These are the main man-made sources, the ones that we emit. You can see that particulate comes mostly from fossil fuels and combustion and dirt from dirt roads, to a lesser degree, construction, agriculture, logging. Lead comes mostly from stuff that we do playing with metals, a little bit from leaded fuels in the US. They're mostly regulated now, and some from like burning trash. Anyway, you should pause and write these down to know their main sources. And remember, like I was saying, you'll want this vocab and this list. The primary pollution is this stuff, the ingredients we make. Some of those are dangerous on their own. Some of them are not regulated. But a lot of them are especially dangerous because they react in the atmosphere to make stuff that's really bad, like nitric acid or sulfuric acid or the oxidants. Overall, systemically, the big polluters are easy to target. Like if you want to build a coal burning power plant, well, you got to put this one filter on that huge chimney and boom, we control power plants. What can be really difficult to control is individual cars. You got to keep track of every one. Like, how do you do that? Every single house, what every guy does in their garage or whatever. Like, there's a bunch of little things that are more difficult to control than the big obvious sources. So the little leaks and the little accidents add up to a lot of air pollution. All right. That is it to air pollution.